Let us look at the concept of monotonic sequence. A sequence is monotonic if it either always increases or always decreases as n increases, which basically means that a monotonic sequence never changes its behavior. So let's see a little bit more in detail. So for all n in the natural numbers, monotonic increasing sequence means a sub n plus 1 is greater than or equal to a sub n. Monotonic decreasing sequence means a sub n plus 1 is less than or equal to a sub n. Monotonic strictly increasing sequence means a sub n plus 1 is greater than a sub n. So the difference between these two is that here it can be equal also. Successive terms could be equal also. But here they can't be equal. Similarly, monotonic strictly decreasing sequence means a sub n plus 1 is less than a sub n. Now, a monotonic increasing sequence is always bounded below by its first term. Since it is continuously increasing, naturally the first term would be the lower bound. Similarly, a monotonic decreasing sequence is always bounded above by its first term. So you should be able to visualize that. Now let's look at a few theorems on this. A monotonic increasing sequence bounded above is always convergent. If a monotonic increasing sequence is bounded above, then the sequence converges to a limit. This limit is the least upper bound or supremum of the sequence. For example, we saw this sequence in the previous session. This sequence is a monotonic increasing sequence which we can say is bounded by 2 above. The limit as n goes to infinity is root 2. So the sequence has an upper bound of 2, and more specifically, square root of 2 is the least upper bound. So that was our first theorem. Now the second is a monotonic decreasing sequence bounded below is convergent. So a monotonic decreasing sequence that is bounded below converges to a limit, meaning that its terms get arbitrarily closer and closer to a particular value. Such a sequence converges to a limit. Again, for example, we saw this previously. 1 by n is bounded below by 0, hence converges. A monotonic increasing sequence which is not bounded above diverges to plus infinity. So if a monotonic increasing sequence is unbounded, then the sequence diverges and does not have a limit. Pretty straightforward example is the sequence of natural numbers itself. Now this is an unbounded monotonic increasing sequence and hence diverges to infinity. A monotonic decreasing sequence which is not bounded below diverges to minus infinity. So a monotonic decreasing sequence that is not bounded below decreases without bound, meaning that its terms get arbitrarily small, that is approach negative infinity. Such a sequence does not converge to a limit. Again, for example, the sequence 2 minus 0.1 times n minus 1 is unbounded, hence divergent. So we have seen a monotonic increasing sequence bounded above is always convergent. A monotonic decreasing sequence bounded below is convergent. A monotonic increasing sequence which is not bounded above diverges to plus infinity, and a monotonic decreasing sequence which is not bounded below diverges to minus infinity. So that was monotonic sequence. Now, if you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.